All right, can everyone hear me? Good. So as Edgar said, my name's Randy Ridgley, and I'm here with Mike and Ralph from PNNL. We're going to talk a lot about Kinesis today, not just Kinesis Analytics, but essentially 3 of the 4 parts to Kinesis. If we just take a look at the agenda really quickly, we're going to talk about the characteristics of streaming data. We're going to dive into what the Kinesis service suite looks like, and then I'll bring PNNL up to discuss how they're using Kinesis to ingest data into their data lake. Just a really quick show of hands. How many people are using real-time streaming today, whether it's Kinesis, Kafka, other streaming services? Okay, good number of people. So this should be a really good session for not only an overview and introduction of our real-time streaming services, but going into some of the more advanced features that are available. So when we talk about real-time streaming, we're really talking about the pace of the data. And what I mean by that is, traditionally, when you're doing batch processing, you're periodically pulling some data. Maybe you're waking a service up every hour to grab some logs, push it into some service, and then run some analysis on it. From there, typically those files are very large files that you're pulling because there is such a long period of time on returning that data. In real-time streaming, you're going to have a very large volume of small messages funneling through a service to do the processing on that. So when you start thinking about what are the differences between batch processing and stream processing, it's really the continuous processing of data in real-time streaming versus the periodic processing of larger data as I'm going through. You can see a couple of examples up here. You might be processing server logs. You want to do that in real time. You're going to be processing those events right away, not waiting an hour to see what's in those logs and then react to that. And that kind of takes me to this slide here where the value of data can decrease over time depending on how you're leveraging that data. And what I mean by that is, all the way on the right there, that historical data still has a lot of value for a lot of the traditional analytics you would run on that. But if you're trying to do things like fraud detection, or you're trying to process clickstream data in real time to react back to the browser or the end user, you really want to be processing that in milliseconds, seconds to minutes, not into those hour, month, and day ranges. So over time, that data quickly decreases. So this is where streaming concepts really come into play, and Kinesis itself is really the driver from an AWS perspective. Some of the common use cases for this, streaming into data lakes, which we'll be talking about a little later here. IoT analytics, maybe you want to capture information on temperature sensors or flow meters for water flowing through systems and react to that in real time. Especially from like a flow meter or temperature perspective, you want to know when something's going wrong right away, not wait an hour or a week or a month later and go, oh, I had a leak, I probably should have reacted to that faster. Smart cities, being able to build intelligence into all of your devices and be able to provide feedback to the back end of process becomes key over time where you really want to do that as fast as possible, not waiting for a later date. So looking at the Kinesis suite of services, we actually have four main categories of services today. I'm going to talk about the first 3 here. We have Kinesis Data Streams, which allows you to have data consumers and data producers, data producers sending data to these streams for consumers to pick up and process. We have Kinesis Data Firehose, which is going to allow you to send data as fast as possible and then buffer data to push into a persistent data store. We have Kinesis Data Analytics, which allows you to tap into those streams and run SQL queries against that data in real time to provide aggregates and statistical analysis of that data. And then finally, we do have Kinesis Video Streams, where you can actually capture video data in real time and process that. So if we talk about Kinesis Data Streams, it's really easy to get started. Anybody that's taken a look at this before, what you'll do is you'll go into the console or the SDK, you define a Kinesis data stream with a name, and you'll give it a number of shards that you want for that particular stream. And that sharding is what's going to determine how much volume that particular stream can take. It's highly durable. It's across multiple availability zones within the region, so you have that durability. And then you're going to have data consumers on the back end of that to pick up those messages and process them as need be. We have a number of tools, and there's a number of open source tools for both ends of that really help you move along in the process. So if we look at some of those producers, if we take a look at the left-hand side here, we do have many ways. We have the AWS SDK and the CLIs. You can do direct puts against that stream with the payloads that you want to send. We have a Kinesis producer library that's going to do some aggregates on the service side to package up multiple messages in a highly performant manner to compress that data and send to the stream to really optimize the usage of that. There's a lot of open source tools like FluentD or Flume that have adapters to connect to Kinesis Streams and send that data to you right away that fits within the patterns that you may have already out there. And then finally, one of the other pieces we have is that we have a Kinesis agent. If you don't know about the Kinesis agent, it's a great tool that is an agent you would install on your services or on your EC2 instances that can pick up and aggregate the data and send it off to that Kinesis stream. As you can see, it all goes into the stream, and then there's a number of consumers. Again, AWS SDK, CLI, the APIs to leverage that data. We have a Kinesis client library. This client library allows you to build applications and deploy them onto EC2 instances. And when you deploy them on those EC2 instances, it can scale out how many consumers you need to process those messages on the stream. You can leverage Lambda. So if you're looking down the road of, I want to build out a serverless architecture end-to-end for my, whatever workload that I'm working on, you can leverage AWS Lambda and pull the data from the Kinesis streams and process that in real time as well. And then there's a few open source technologies that are available to you. You can leverage Apache Storm and set it up and process that data. Or what a lot of people have been leveraging, and it is one of the more popular frameworks out there, is utilizing Apache Spark to be able to pull the data off, process it, and push it into the places that you're looking for it to go. So Kinesis Data Streams was the first service that we provided about 4-ish or so years ago. And as we were working with customers, we found they were using Kinesis Data Streams, and the biggest use case they were doing was they wanted to process data and be able to handle the volume of data coming through, whether it was clickstream or IoT data, and just get it into a persistent store so that somebody could process that data after the fact. And so what we built was Kinesis Data Firehose. With this service, it's zero administration, and it'll scale to the volume of data that you're pushing to it. And what you end up doing is picking one of 4 sources of persistent stores today. You can say, I want to send data to S3 and get it in there as fast as possible. I want to push it into my Redshift data warehouse for my BI folks or people doing visualizations off of that data. Push it into Elasticsearch. And then one service that we have that isn't part of the AWS ecosystem, but one of our partners, because of the popularity of Splunk, we have an adapter for pushing data into Splunk as well. The nice thing about Kinesis Data Firehose is you've got a couple of levers and to do buffering. And what I mean by that is as you're pushing those individual small packets of data into this Kinesis Data Firehose, you want to be able to aggregate those and push them into S3 so that you can utilize some of the strengths of the analytics engines on the back end there. So the 2 levers that you have for Kinesis Data Firehose is I want to stream data up to, say, 15 minutes by time, or by size, I want 100 meg files before I persist that data out to that data store. So what you'll have, for example, with S3, you may allow some latency within the streaming portion of your data, but you want to bulk up and push larger files to S3, you might say, I want every hour to push out that data to that persistent store. AWS is going to take care of the durability of that Firehose while it's up and running. It's serverless, and it scales elastically with the load that you have. One side note that I'll put in here, there's actually two features I'd like to talk about that are relatively new this year. You have Lambda functions that you can apply to do transformations of that data before it goes to that persistent store. And then just about a month ago, we announced pushing and transforming that raw data, which might be CSV files, XML, JSON, into Parquet format and registering it with our Glue data catalog. So essentially making it a one-stop shop to get your data in as fast as possible, get it into that columnar format in your data lake, and be able to run processing with multiple analytics engines on the back end, and, in real time and as fast as possible. The next service, which I'm going to dive into a little deeper here, just to let people see how easy it is to build these aggregates out, is leveraging Kinesis Data Analytics. So with Kinesis Data Analytics, essentially what you're doing is tapping into those Kinesis Data Streams or the Kinesis Data Firehose in real time while the data is going through there and acting on it, leveraging standard ANSI SQL. It scales itself as well to the volume of data that you're pushing to it, and it's very easy to get set up and started. There's really 3 steps that you'll have with creating a Kinesis Data Analytics application. The first thing is you're going to have your source input, which is one of those Kinesis Data Streams or Data Firehoses. You're going to write some SQL code that allows you to ingest that data off of that stream and then start running your transformations in there. And then you're going to continuously deliver those results to another Kinesis data stream or Firehose to be able to use downstream somewhere else. So what you'll see is you can start chaining these services together to build a really in-depth, rich pipeline for the data flowing through your systems. What happens with Kinesis Data Analytics is, as I mentioned, you have a stream, a data stream or a data firehose that you're connecting to. If the data, say, for example, is CSV data or JSON data, or a number of formats that we support, what is actually happening under the covers is it's converting that data into a table-like format for you to then build those SQL queries off of, and it's very familiar to people that are comfortable working in SQL. And at that point, it supports a number of functions, statistical functions, nested data within the JSON structure, allowing you to then build out multiple step processes of processing that SQL data. All of this happens in sub-second, end-to-end, depending on how in-depth those queries are and the types of aggregates you're doing. For example, maybe you have a click stream coming in off of your website, and you want to know how many active users are on the site at any given time. You can tap in this Kinesis Analytics service and do some of those summations or aggregates based on the data coming in real time and produce those outputs to another stream. There's pre-built functions for all of that, and there's also, I'm going to touch on a little bit, and PNNL is going to go into some more detail on this as well, is there's some built-in machine learning functions that you can leverage with Kinesis Analytics, so you don't necessarily have to have that background of understanding of the deep knowledge required to build these algorithms. You get the ability to leverage them for things like fraud detection, anomaly detection, hotspot detection, and things of that nature. So the way you do that is there's 2 main concepts with Kinesis Analytics. You're going to create a stream, and that stream is that stream of data that you have funneling in that comes up in table format. So in this example here, you can see we're creating a table of the number of calls per IP coming through that stream. It's got very familiar SQL for you. You've got the data types that you can leverage. And what that's going to do is create an in-memory table to start funneling that data into. The second piece to that is you're going to have what we call a pump. And what the pump does is does the actual insert information so that you create these select statements of the data you want to ingest into that stream that you've defined. And it's going to do that in real time and aggregate all of that data up. So then, things like doing a count on the number of distinct users that are currently in this 5-minute window, we can process that data, see that data in real time, and report back or utilize that data in other systems. And the way we do that is through defining windows of time. So traditionally with standard SQL, you already know what the size of the data is within my tables because I have that structure defined. Because the data is real-time streaming, it's constantly changing. So you have to put some bounds around how much data do I want to ingest and process in a particular time frame. The way you do that is with these windows. There's a few types of windows and then that are built in, and you can also create custom windows. The first window is a sliding window. So think of that as I may have a 10-minute sliding window that I'm working off of. This window slides every 10 minutes. So there'll be some overlap of data between the windows that you may need to work with. The next one is our tumbling windows. These windows are distinct sets of time that you define that tumble over each other that won't have overlapping data coming in across those windows. So depending on the implementation that you're looking for will help you determine what types of windows you want to leverage. You can create session windows so that you have a window of time per those sessions that you may be defining within your clickstream environments. And then, as I mentioned, you can create some custom windows as well. And then finally, the last thing that I want to talk about is we have these built-in algorithms, machine learning algorithms, for you to leverage day one. The great thing about them is, again, like I mentioned, you don't have to have that deep understanding. As long as you understand how to utilize those types of algorithms, you can leverage them in your Kinesis Analytics applications. The three that we're calling out here are the anomaly detection. So there's certain parameters that you would pass in when you're defining that select statement to this algorithm to determine the window size that I want to leverage, as well as some of the metrics for the parameters around utilizing that algorithm. And with anomaly detection, you'll be able to see those unique spikes and be able to report on those in real time, as opposed to trying to process that data later and go, oh, I did have something that looks odd here. I want to report on that now, not later. And then we also have hotspot detection. So if you're doing things like a bunch of IoT sensors or temperature sensors and things, you've got a large data collection in a particular group, you may want to report on that and be able to provide value back to downstream systems to let them know. All of these machine learning algorithms are unsupervised, if you're familiar with the concepts of machine learning. So what happens is they're going to learn over time based on the data that you're feeding it. So it is really critical to understand your data, but then be able to feed that algorithm appropriately. They're all adaptive, and they're all done in real time. So with that, I'm going to bring up, Ralph, you going first? Ralph, who's going to talk a little bit about ingesting data into his data lake, leveraging Kinesis.
Thank you. Thank you, Randy. Like Randy said, my name is Ralph Perko, and I'm with Mike Giardinelli. We're from Pacific Northwest National Lab. We're both software engineers, and we've been out on AWS for several years now. More and more, we continue to move towards a serverless environment. So we're going to talk a little bit about how we've implemented a serverless data lake, in addition to how we're using various aspects of Kinesis, and then also we'll follow up with what we're doing next regarding serverless and our path forward there. So I thought I'd start with setting a base definition for a data lake. You know, data lake is a buzzword. You see it advertised in various places. So for the sake of this presentation, we'll call a data lake an architecture that allows you to collect, store, process, and analyze, consume all data that flows into your organization. Now, that's pretty general. Below it, a more practical definition, perhaps, it's a collection of technologies, services, and best practices around a large repository of raw data. I think that raw data part is the important piece to call out here, because if you think about this, you're like, well, why don't you just use a database or something to store all your data? And the reason is because you have this raw data coming in. One of the core tenets of a data lake is raw data is coming in and you never get rid of it. You store it as is because you never know when you're going to need it. And that's why it's usually associated with something like a Hadoop system, originally at least, where you have distributed file system. And now the next evolution of the data lake is out on the cloud. AWS S3 is a fantastic candidate for that. So what does a data lake do exactly, right? So there's some core features that you need to have in a data lake. You need to be able to get the data into the data lake, ingest the data. You need to be able to transform it. So even though you're saving that raw data, you're eventually going to want to do something with that data. So you're going to want to transform it into some other format and make it more usable. You want to be able to analyze the data. That's why you have it in there, correlate it with other data sources and whatnot. Store that data or archive that data. That's where S3, again, is just fantastic because with the lifecycle rules, you can just have this stuff roll off into Glacier. I think our rules are set up by default to 90 days. And then extract the data. You want to be able to get the data out. And that can be something literally, somebody downloading the data to pushing that into something like an enterprise data warehouse or a relational database, Elasticsearch, something like that. Skipping replay, I'll come back to that, and then got data provenance, data security, other enterprise features, based on what you need. And then going back to the replay data, that's something that we take advantage of quite a bit. And what I mean by replaying data is the ability to take some well-defined data set that is around an event or a time frame or whatnot and make that data available, particularly to researchers who might be working on a particular algorithm, doing some data science, and they need some notion of ground truth to be able to test the work that they're doing. And we take advantage of that, building that capability in. So what do we use our data lake for? First, it's a centralized data repository. We have a lot of different disparate data sources that we have coming in, and there's some examples there. Of course, data science and analytics. Having the data in S3, you have the entire suite of AWS services at your disposal then to interact with that data, and that's really powerful. And then third is collaboration, which is always near and dear to our hearts. We're a national lab. We do a lot of collaborative work. Internally, we're collaborating with researchers and other engineers, and then also with our government sponsors or customers and external partners like universities or other national labs. So what does our serverless data lake look like? This picture here, it's not ours. It's from an AWS blog that I grabbed this from. This was our inspiration, if you will. So first, a little bit of background. We do have a data lake internally. We have several Hadoop systems at the lab, and one on our program in particular, it's, 42 or 44 node cluster. It's a decent size. And so we'd already had a data lake internally. We're already familiar with the concepts and the best practices around that, which translated very well out to the cloud. But as more and more of our data was out on AWS, and we were realizing that, wow, it's an extra step to continue to bring it in, and there's so much capability available, we decided let's just go ahead and formalize this a little more and make our data lake external out on AWS. Now, we do still have our internal Hadoop cluster, and we will continue to use that. There's just some data, for example, that we just need to keep internal. But by and by, we've all the data that we ingest is usually out on the cloud, and so we have moved in that direction. Just talking through this really quickly, from left to right, the data's coming in on those arrows. You see those buckets and the little spider icons, right? These glue web crawlers are being used to analyze the data in an S3 bucket, making that data then available in Athena, and then you can use a variety of services to access that data. And that's pretty similar to how we've set up ours. So taking a quick look at the technologies we use in particular and what our implementation actually looks like, just calling out there some of the main technologies. So, excuse me. First on the ingest, you use Apache NiFi quite a bit, and also AWS Lambda. So the one thing with data ingest, and actually all these services, it's very use case dependent. There's not a one-size-fits-all typically for a data lake, unless all your data is just coming from one source. But when you have a lot of disparate sources, it come into a lot of unique situations. So from ingest perspective, the first question you need to ask yourself is what kind of control and access do you have to the data? Do you control the data? Is the data, are you pulling the data in, or is it being pushed to you? Is it on your network? Did somebody hand you a DVD and you need to get it out there? So these are all questions to consider when you're thinking about how to get your data into your data lake. And depending on the situation, we typically go with either NiFi or Lambda. From there, we push our data onto a messaging queue system, typically either Kinesis or SQS. We also use SNS as well. Internally, most of our systems are message-driven, our architectures. That keeps them decoupled and then also makes them much simpler to distribute and scale. So we found that as an effective pattern for us. From an ETL perspective, then, we use AWS Glue to do transformations from JSON into Parquet quite a bit. And although we'll talk about the Firehose and how we use that as well to do that very same thing. But the nice thing about Glue is you can also write your own custom Spark jobs, which we have done to take care of some different nuances. Again, Apache NiFi. We have a suite of enrichments that we have written over the years, and we haven't completely ported all those to Lambda, although as opportunities come up, we're moving more and more to the serverless just so we don't have that administrative overhead of a server. Storage, I have S3 here. That is the foundation. However, there's other storage mechanisms we use as well. The data is pushed oftentimes in RDS or Elasticsearch or into Redshift. So there's a variety of technologies we use there. But S3 is by and large the foundation that we lay. And then from the analytics side, again, just calling out some examples here, Kinesis Analytics, Lambda, Athena. Athena is great. That's really pretty much almost entirely replaced internally our Hive implementation. The ability to use Glue to crawl the data and get a schema and be able to then access it quickly with Athena has just been huge. And then Amazon EMR, of course, which is MapReduce. You got Hadoop, Spark, Zeppelin, R, whole variety, Python, variety of tools that you can use out there. So, all right, with that, I'm just going to walk through a data flow really quick. This is one we have right now, and just discuss how we're using some of these technologies. So it says news feed. It's probably better to call it an RSS feed. A lot of it is news, but we also have Reddit and other data that's coming in here. And so let me just describe this diagram really quick. On the top, we have an arrow going left to right. That's the data as it's coming in. It's flowing into the system. Below, we have, you see Amazon S3, and the data is being stored there, and then the variety of services that are available to you once the data is in there. And then the arrows going down is the various places in the pipeline where we're pushing the data into S3. So the data is coming in this case, they're RSS feeds, so they're in XML, and we're ingesting it using Apache NiFi. And then trying to stay true to the tenets of a data lake, we immediately push that data into S3, so that data is then available for future use if we need it. Then we put that payload onto SQS, again, decoupling that ingest from the processing. In case things go go sideways downstream, by separating your ingest from the processing, you ensure that your streaming data continues to flow in. It's at this point that we start applying some enrichments, again, using Apache NiFi. And this is where we start taking advantage of Kinesis Firehose to push that data into S3. What's really nice about Kinesis Firehose in this respect is that the way it puts the data into S3 is a really nice directory structure that partitions really well for use with Athena and the web crawlers, and we take full advantage of that. That replaces some NiFi flows that we have that we were doing that very thing. So now it's just one call into the Firehose. And then onward to the right here, we got a variety of other functions that we're using. We're using Lambda then to do some other enrichments. What's really cool about this is that it's dynamic, and that's what one of the benefits that we found is that we in the past a lot of our Lambda functions would be written in Java and we'd be deploying them out there. But more and more, we're taking advantage of Python. And so we're able to then just tie into our pipeline fairly easily to do some new analytic. And then you see where this data is being pushed into S3. You can pick and choose where in the pipeline you want to do that. So there may be a specific use case where we've called some Lambda functions and we want to go ahead and push that data in, or perhaps that use case goes away and we just abandon that and let the data go through. So in this case here, we got, starting with that first Lambda, we're doing an enrichment there. It gets pushed to Kinesis Streams. At that point, it also goes to the Firehose. We have another Lambda function. That one's actually a preprocessor to the Kinesis Analytics. And Mike's going to talk a little bit more about that. And when those analytics come out, it goes push it into the Firehose. And then once all the data is in there, we can use a variety of services below, AWS Glue, Athena, EMR, QuickSight, and then our own custom analytics as well. So with that, I'm going to hand this off to Mike Giardinelli, and he's going to talk a little bit more about Kinesis.
All right, thanks, Ralph. Make sure I don't trip here. So what I'm going to do is I'm going to recap the suite of Kinesis services that we're actually using, which is the Firehose, the Streams, and the Analytics. And I'm going to actually walk you through an actual use case that we actually put together that Ralph touched on previously in that previous diagram. So starting with the Firehose, and Ralph's touched on some of this, but we're starting to really move towards using Firehose for a lot of our ingest pipelines. And a lot of the value add that we get out of it is how easy it is to just do the bundling, compression, and partitioning and things like that to really set up the data for analysis and other needs that we have in our space. And one of the key parts there is that we do use NiFi quite heavily, Apache NiFi, and we love it. But there are some things about it that have started to become really problematic for us. And some of that's just the administration part of it, the administrative overhead that you have, along with some of the configuration management and things as you start to deploy out these solutions or these pipelines. And Kinesis has been just a better fit for us there. And then the other part is, as I mentioned, is just trying to really quickly get it in the hands of our researchers and scientists and analysts so that they can help assess and help us understand if the data we're bringing in is positioned the way that they want, if there's other modifications or enrichments or whatever that we need to do to actually more enrich it or better position, I guess, for whatever it is that they want to do. And then last piece I just want to mention is, you can do quite a bit with the actual Firehose piece itself, meaning the transformations and optimizations and things like that. But one of the things we encountered when we were bringing some of our stuff in is that some of the data sources we had some fairly complicated JSON nested structures. And we actually had to use Spark jobs instead just because we were having problems actually getting it into the Parquet format. So just something to note if you're going through that process, just keep that in mind. And with Streams, so somewhat similar to the Firehose, just in that we're starting to look at seeing if we can actually port some of our pre-existing NiFi pipelines where we're doing a lot of enrichments, analytics, and transformations into leveraging Kinesis Streams in analytics instead for a lot of the same reasons. The administrative overhead, configuration management, and then just simply because of the analytics and things that our teams want to run are pretty diverse. And Lambda in particular is very well suited for that. And then one of the other key parts is making sure that we can try to deliver more targeted, directed data streams. So a lot of the models, machine learning implementations, applications, things like that are better suited and provide a lot more, accurate results, if you will, if you're providing them more directed streams. And using NiFi and other things, you can do that, but it seems to be harder. It seems to be a little more difficult. And Kinesis Streams with the dynamic routing and things like that you can do is better positioned, at least from what we've seen to do that. And then the last piece, the Kinesis Analytics. So we are starting to leverage a lot of the functionality out of the analytics side of Kinesis where we can actually build these targeted streams. So one of the things we do is we try to eliminate what we call the junk, right? Like eliminate the stuff that people don't care about. Try to actually provide them with the relevant data, the relevant content that they actually are looking for. And then use the filtering logic also to do things like route things that require specific content, so like the models themselves. Like language is a good example of that, right? If you have, like a Spanish-based model or something, you obviously don't want to send it English, right? And you can use the criteria or SQL logic directly in Kinesis Analytics to do that. And then one of the other things is we're starting to add a lot more capability to bring users into the loop, like allow them to engage in these flows and these data streams so they can help us build up these training sets so that we can actually then build out these machine learning instantiations and leverage the content that's being derived from that, the tagging, the labeling, all that stuff to do additional filtering and things. And then the aggregations is really powerful. So a lot of what we've had to do in the past is of course, store the details, run the aggregations, perform the summarizations, all those kinds of things, so we can actually get the data into a state that's needed for alerting or outlier detection or whatever analytic it is that needs that type of input signature. Instead of having to actually persist it first, we can actually do some of these aggregations in line, in the stream directly, especially if we actually are doing some upfront filtering and enrichments and modifications to it. So it's really, really powerful. Not have to store it first. We can actually persist it in an aggregated state or pass it directly to the analytic. And then the other part is just taking advantage, and Randy touched on this, taking advantage of some of the out-of-the-box capabilities, things like anomaly detection. We have our own custom ones and things like that we build, but it's nice that we can attach new ones, or different ones, I guess, if you will, within the Kinesis suite. All right, so it always helps, at least Ralph and I, we talk about this a lot, it always helps to actually have a use case to walk through or to describe, how you can actually leverage these tools. And in this case, we had started to use Firehose and things to do our ingest, and we actually wanted to take a look at the other suite of tools, at least the streams and the analytics, and we had something that come up, this news feed that Ralph was talking about, where we actually did want to aggregate the content, we needed to make enrichments and modifications to perform ETL, and then we actually wanted to integrate it with some of our existing anomaly detection capabilities that we had built, and we thought, hey, let's just attach the out-of-the-box one too. So just as a side note there, within the Kinesis suite, it's really easy to just attach a template or grab a template and use that as a starting place. So I really highly encourage you to do that. That's what we did here. So the first part of this build out for this use case is constructing the schemas. So just like you do with a relational database, it's really important to understand for your use case what the data structures need to look like. So that's what we had done, is that we knew that we needed to position this raw content or get it into a state where we could actually perform the aggregations we wanted to have, and then also make sure we had the data elements we needed to actually attach the anomaly detection. There actually is one flaw in this slide that I noticed later, and that's the roll-up timestamp there on the aggregate schema is actually a timestamp, it's not an integer. So I saw that after the fact, just as a side note. So in order to actually get the data into the structure that we wanted, we actually are attaching what's called a preprocessor to one of our Kinesis streams, and this is really awesome. I mean, we basically were able to take a Lambda function, generate the logic or create the logic within that Lambda function and then attach it to this stream so that as data is coming through this stream, it's actually running this logic on it, performing the enrichments, doing the extractions, doing some of the transformations we needed to actually get it into that payload, get it into that state, which is really nice. If you haven't used Lambda, hopefully most of you in here have, it's phenomenal. We use it all over the place now for a lot of our logic and processing just because of how easy it is to build these containers and deploy them and reuse them. So this is just a snippet of what the actual Lambda code looks like. It's a Python-based Lambda function, and what we did is we built just a deployment package locally where we could quickly evaluate if the logic was right, just run some basic tests through it and make sure that it was converting it, enriching it the way that we wanted. And then we actually deployed that out, and we're using the built-in test harness that's out there that actually has an input signature that matches what you get from a Kinesis stream, and we just made some minor modifications to it so we actually could test it as it was deployed, make some minor adjustments in the console, and then once we got it into that state, it was ready to go. And we used the deployment package mainly just because there were some libraries and things that we wanted to take advantage of that we wanted to package up and use that as part of the deployment. So then the next step, so we define our schemas, we performed the pre-processing where we were doing the enrichment, the ETL on the data. The next step was actually to generate the actual aggregations that we wanted out of the stream. And then Randy touched on this. It's just SQL. It's just pure SQL that we were able to write against this streamed, enriched, transformed data. And so what you see is that we're actually doing groupings or roll-ups by the source, which is the URL, on some of the other elements or components that we were exposing within this data. So aside from the source counts, we were actually looking at named entity recognition. So it's identifying the people, places, organizations, things like that within the content based on one of the deployments that we had. And the other couple things to note here, one is that we're using the tumbling window. So this is the non-overlap approach. We wanted to actually have these very segmented roll-ups of data. That's what the input signature was required, or that we wanted to have required for the anomaly detection. And then our internal custom ones also rely on that. So we use the tumbling window approach. And if you look at the end of this SQL where it says 600 to second, that's where we were describing that time frame that we wanted to actually group by, which is roughly 10 minutes. At least for our other anomaly detection capabilities, we found that 10 minutes is about the most granular signal we could we could aggregate on where an analyst or a researcher could actually make some sense of when an anomaly occurs. So that's why we use that. And then the other thing to note is we actually dropped in the current row timestamp function in here because one of the things that we wanted to make sure and enable was that if somebody did see something out of whack or out of norm, so either the aggregate data itself or the anomalies, they could actually drill into the rough time frame and do some searches and queries on the raw data just to see if they could better understand what was going on. And then the screenshot there is from the aggregated data that we're building or deriving here, we're actually writing it to a destination, which is another Kinesis stream in this case. And what's really powerful about that is you can actually build these new streams where other applications or consumers can leverage what you're doing here directly in the stream. Really, really nice, really, really powerful. And this is kind of in line with what I mentioned earlier about some of the complexity we would have some of our pre-existing flows that this is helping us with. So then the next step is, okay, we derived the schemas, we applied our ETL, we actually are performing the aggregations. Now we actually wanted to attach or apply the anomaly detection. And in this case, and I highlighted it in red just so it was apparent what we were doing, is we're actually using the random cut forest with explanation anomaly detection. And the reason we chose that over just the random cut forest one is that we actually wanted the metadata that comes with the anomaly score to be part of the feed. And the metadata actually gives you insight into the direction and the reasons for which the anomaly is being derived, right? So we were using it not that we will keep it in the feed, but we were just doing it so we had a better understanding of why the scores were coming out the way they were. And then the other part of it is, just like we did with the aggregations, is we were building another destination. So we were building another output feed that we could leverage or use for the actual analysis itself once we had, or now that we had the aggregations and the anomalies. And so this is essentially redundant to my previous slide. It's just that I wanted to show you what it looks like directly in the console. So the console is really powerful. You can actually, of course, apply your SQL. You can run it. You can evaluate the source data as it's coming in just so you get an idea of what the data looks like. And then you can, of course, evaluate the logic that you've applied in that real-time analysis window down there at the bottom. So what it's doing is it's periodically running samples on the logic that you applied, and you can actually see what's being spit out just to see if it's in line with what you're expecting. And so, we're rolling up on the sources, the counts, the named entities, and then the timestamp, which is being derived, and then a little snippet there is the anomaly score itself. And then the next piece I just wanted to highlight is very similar to the aggregations, which is then we're actually deriving or pushing this data to a Firehose delivery stream in this case instead of a Kinesis stream. And the reason that we were pushing it to a Firehose stream is we actually wanted to load this output, this data actually back into our data lake, the data lake Ralph was talking about, and make it available for other processing and analysis that we wanted to have happen or enable for our researchers and scientists and things like that for their ability to take a look at the content and see if it's in line with what they wanted. And so the other part is, it's unfortunate I left it out, I wish I would have put it in here, is that Ralph was talking about the glue crawlers. And so the next thing that we did is once we started landing the data into our S3 repositories is that we ran glue crawlers on it to auto-generate the schema. And so once you have that auto-generated schema, then you can actually start to write SQL through the Athena to actually further evaluate your data, which is really, really powerful. We found actually pretty quickly up front that I think that I'd made some mistakes on like the time windowing, and then I'd realized that I'd actually left out one of the named entities that I wanted to apply. I think it was location, and I should have noticed that or recognized that right in the Kinesis console, but I didn't, and I was actually then able to run some Athena queries and things to identify that both in the schema structure and then the rollups. And it's really, really powerful within it. Seriously, I think it was like a matter of minutes of dumping the data. I actually could come out here and take a look at the data and do the rollups and start to see or identify if the data, the signature was what I wanted, and then I came back the next day and looked at the actual results. And just something to know, it's kind of interesting. I mean, I don't know if there's anything of value here or not, but if you look at the second and third rows, and it's maybe a little hard to see, you can tell that the anomaly score is a lot higher on the second row, even though the URL count's less. And the reason for that is the entities that are being identified from that source within that time frame are a lot higher. Again, does that identify anything of importance? Not sure, but the reason for doing this, or the reason we're applying these algorithms to this data, is we want to highlight cases of where the sources are having things occur out of norm. And so what you would expect is that if you're starting to see a lot more people or locations or organizations, or maybe a combination of them, mentioned more frequently, it's usually an indication of some sort of event occurring, right? Or at least that's the intention. And so we've gotten just a ton of value out of bringing these things together, and I think we did it, and it was the initial attempt at least was pretty quick, right? In a matter of days or something like that. We were actually able to assemble these things pretty quickly and get it in front of people and have them start to give us feedback. Instead of spending a lot of time on the engineering part, only to find out that you've made a lot of issues, or you've encountered a lot of issues in the way that you put it together that maybe doesn't match their needs or meet their needs. So what's next for us? I think we're really, or I guess Ralph would probably agree with me, we're really just kind of scratching the surface on what we can do with some of these Kinesis streams, the analytics and the Firehose and all that. And so we want to start, or we're going to continue to look at other areas where we can make adjustments or migrations into this platform. We do a lot of enrichments and analytic integrations and things like that, and so we're going to be looking at that. We also use a lot of pre-existing AWS services, so things like AWS recognition, which is identifying image classes or image classifiers within content, or within the imagery themselves, I mean. And so because of the data that you get out of those feeds or out of that service, we actually can start to use those for our filtering and aggregations and even maybe anomaly detection. Like start to determine if you've got imagery of certain kinds that stand out from a feed, if you will. And then the other part is making it easier, or starting to incorporate a lot of the input that we're getting, again, from our users that I touched on earlier. They're helping us building out these training sets and things like that, and then applying the machine learning aspects to it and the tagging and labeling, again, that we get from that and starting to use it. So anyways, that's the end of the use case. That's the end of our presentation. Just wanted to say thanks. Really appreciate Randy and Cindy asking us to come up here and talk again. Really appreciate your time. So thank you.
And if you guys could, really quickly, if you guys could,